Hello explorers and welcome to another video. Today we are going to tackle day 22 of Advent of Code. So let's just jump right into it. So, operating these extreme ocean depths has overloaded the submarine's reactor and it needs to be rebooted. The reactor core is made up of three large three-dimensional grid made up entirely of cubes. One cube per integer, three-dimensional coordinates x, y, z. Each can be either on or off. At the start of the reboot process, they are all off. Could it be an old model of a reactor you have seen before? So this is linked to 2020, day 17. To reboot the reactor, you need to set all of the cubes on either on or off by following a list of reboot steps, your puzzle input. Each step specifies a cuboid, a set of cubes that are coordinates would fall within ranges of x, y, z, and whether to turn off the cubes in that cuboid or on. For example, giving these reboot steps. The first step, and the second step, and the final step. After this last step, 39 cubes are on. The initialization process only uses cubes that are within x, y, z positions that are at least minus 50 and at most plus 50. For now, ignore cubes outside of this region. Here's a larger example. The last two steps are fully outside of the initialization procedure area. All other steps are fully within. After executing these steps in the initialization procedure region, 590,784 cubes are on. Execute the reboot steps. After that, consider only the cubes in the region minus 50 and plus 50. How many cubes are on? So what I will do here is probably creating a cuboid and storing the result of that, and then checking just the region, and for each of these cubes in the region, see if it's on or off for each cuboid. That's the first check I will do and see if that is performant enough. So I will get on to code a bit about that and I'll be right back with ya. And we are back, and what I've done here is pretty much creating this cuboid. And the cuboid is parsing a string, and it has x, y, and z positions and a boolean if it's on, and this boolean is null if it's not set at all. Then we go through and check if it's this specific line starts with on, then we will set it to true. So we can go look here at one of these examples. So here we have this example. So the first thing that should be there is on, and if so, we will set it true. Then I will trim the result, remove 3. So I will remove on or off, and then trim off the extra, and then split it up with the colon. So I get each of these coordinates. I go through each, and we can look at the x. The other ones are similar, just a different position. So I will look at this part, and I will check if it starts with this x equals. Then I will split it on these points or dots. And what I get back then is 2 dots. I will get the first and the second, because I don't know which one is the smallest. I would guess the first one is that, but we can't be sure of that. So then I will do this math min and max to get the smallest and the largest of the values and put into x1 and x2. So I know that x1 is the smallest, x2 is the largest. I can have this function where I check one specific coordinate, and if x is smaller than x1, then it's not there, so it's just null. If it's larger than x2, then it's just null again. And if none of these are okay, then I will just return the value that's set, either false or true. And in this run here, I will read in, first I read in the data up here, and then I read in the file as cuboids. And then I will go through every position between -50 to +50. And I will go through every cuboid and get the value of the on parameter if it's there. So this will either be null or on or off. And if it's either one of those, I will count it. If it's on, of course, then I will count it. And then I print out the count value here. So we got 576,028. So let's see if that is the right value. Let's see here that I didn't fix that. So now you see it. So 560,028. So let's go here and paste that in and run it. Yeah, you get a gold star. I get a gold star. Everybody gets a gold star. So let's look at part 2. Now that the initialization procedure is complete, you can boot the reactor. Starting with all cubes off, run all the reboot steps of the cubes in the reactor. Consider the following steps, and then you have a bunch of them. After running the above reboot step, 27th, a bunch of cubes are on, just for fun. 574,140 of those are also in the initialization procedure region. Okay, starting again, all of the cubes are off. Execute all the boot steps. After that, consider all cubes. How many cubes are on? So I need to keep the value that I have now. Then I need to make something that can count how large the region is. And I also need to figure out a way to split regions off by thinking about merging regions and splitting regions. So one cuboid, if it intersects with another cuboid, could create multiple other cuboids. So this is a little bit of just a graphical thing to figure out, and I will do a lot of different mathy things. But if I get to a conclusion, I will get back to you. And we are back. So let's see if I got the right value here. I've tried this a bunch of times. So let's see. Yeah, you get a gold star. I get a gold star. Everybody gets a gold star. So what did we do here? So this first off here is that I've tried a bunch of time to get the test data right. And then I had a couple of times to get the real data right as well. So what is this function I have built here? There is so much. So first off, we have a bunch of data up here. The simple example we have up here is 2 on and 1 off region that we need to handle. And what I do is that I read in something that I call initial cuboids. And these are things that are parsed by the line that we saw above. So you can take a line in, check if it's on, and then put that on. And I also set an ID here. And that is to know in which order things are added. And then I also take these chords and parse those out as x1, x2, y1, y2, z1, z2. So that's one way of creating cuboids. And I also note if they are already splitted up in more cuboids. So that is something that I need to keep track on. I can create new cuboids by just giving it all the input data, and all the new ones that I create are lit one. So I will never create any ones that are dark. And I also have this function to check if it's on. And that's mainly used when I want to check the smaller area. So in my code over here, I actually have one where I go through the small area that we had earlier just to see that that test data is correct as well. What do I do here? I have this initial cuboids list, and while that is not empty, I will add the first one to my cuboids list, and that's just a list, and I remove it from the initial. So I will add a new one every time, and then I will try to get the big cluster to calculate all the cuboids that will be in it until I add one more, and then calculate everything again, add one more, and so on. Then I set a new ID for these cuboids, and I add 1,000 between each ID, just so I make sure that they don't collide with each other. So I know that if I add new cuboids, I can add them after the current cuboid without colliding with the next cuboid. Then I have this intersect count, and that is how many has intersected. I just set it 1 so I will get into the while loop. And then I will create an intersect map, so I see how many have intersected in this round, or which have intersected with which other ones. And I also have a list of things that haven't intersected at all. Then I set the intersect count to 0, and I go through all cuboids and check them against all other cuboids. And if they are not splitted, because those I'm not interested in, should not be any left at this point, but I have these anyway, and it's not the same cuboid, then I check if it intersects with the other cuboid. Very simple function here, just checking if they are in the same area, pretty much. A pretty neat function. And then we have, if this intersect map already contains the first one, not contains the first one, we will create a new list for that one. If it contains the second one and it already is connected with the first one, then we don't add it again. Otherwise, we will add into the first one's list, we will add the second one and increment the count here. So now we have a bunch of intersecting things, and then we will add all those that are not intersecting and not splitted and is still on. So we have a bunch of cuboids there. Then I will go through here and check if this first entry here is not splitted, and I can split it. So then I split it. Else I will just add every other one in this intersection that is not splitted. So this is to split them up and also add all that aren't splitted. Then I get a long list of splitted ones, and then I will go through each of them and see that I don't have any additional ones that have been splitted into something and should be removed, and that all of them are still on, so I will add them back again, and then I will put the cuboids from the no intersect back to the cuboids. And I will do that over and over again until I don't have anything that is intersecting anymore. And when that's the case, I go back and add another one and do that over and over and over again. And last but not least, I will count the size here with a big integer. So I will go through all the cuboids and ask for the size. And this is the size calculation, pretty much x, y. Add 1 because we are inclusive, so we all need the end of this also. So we can't only have the distance, we need one more. And then I will multiply those together. I can check if something is on, if it has been splitted, and set an ID. This toString I added just to see similar as we had with the input data. So I had a good look at that. I could set that this splitted. So what is actually splitting things? Well, we go up here and let's see. So we have gone through all the code here on here. So now we are at split. So we get a list of things to split. Because it's a list, we need to go through all of them, of course. This is just take all of them and then split them. And a split function will check this cuboid and trying to split it with the other cuboid. So we set this is the first one and the other one is the second one. And then we'll check the IDs if we need to switch these around. Because there might be that the ID of this is further down the list than the actual one that we want to split with. So then that should be the first one. And if both of them are on, we need to do a merge. And a merge is much better to do with the largest first. So here I will check the size of them and pick out the largest and put that first, and the other one will be second. So that is in order to split up the small one in smaller cuboids and keep as large ones as possible. And then I will do a merge here with the first and second, which it pretty much is cutting out the other part that isn't in the first one, and then add the first one as well. So I will have add all other parts and the first one. And if none of them are on, return the empty list because we don't have anything that we want to add. If the first one is not on but the second one is on, then we just return the second one, because then we don't really need to merge or cut or split or anything. If the first one is on but the second one is off, we need to cut away the things that are off, pretty much. So that's the split function. The cut function, very simple as well, goes through and checks if the first coordinate is smaller than the second first x coordinate. Then I need to cut off what's left of it, pretty much, in the xy coordinates. So I go from the first x1 to the second -1. So that's what I want to cut away, pretty much, or what I want to keep. And the same goes for the other way around. Then I would take x2 plus 1 and then to first x2. So this is the way to cut off the edges and keep blocks on the edges of my larger one. And in this case, when we cut, we want to remove this other this other cube that is intersecting with this cube. So we cut off these ends, and then we cut off more ends and so on, and we return that list, and that is telling us that the large cube is pretty much cut up in smaller cubes. When we do a merge, we just check first that this second cube isn't within the first cube, and if it is, then it's already included, splitted, or what you want, and we will just return an empty list because the first one will be the one. Otherwise, we will do similar to what we did with the cutting, that we will take the edge blocks around this cube and pick those out and return. Yeah, so this has been a lot of tedious work, a lot of debugging, but I finally found an algorithm that gave me the right result, and I'm so happy about that. If you have a better way to solve this, I would love to hear about it in the comment section down below. If you haven't subscribed yet, please do that. If you like this video, give it a like, share it with your friends and colleagues. If you didn't like it, give it a dislike. And I really hope to see you in the next video.